So tonight, one of the things that we're going to start working with is going to be statistics. And this is when we take data and lots of data and we try to analyze data and find meaning in data. And one of the words that you'll hear thrown around a lot when people talk about data is an average. And that's a pretty broad term, actually, and it can mean several different things. A better way to think about average is a central tendency. When you have a group of numbers and we're looking for a number to kind of represent tendency, uh, that is totally misspelled, so just ignore that. But the average can actually be computed in a couple of different ways. The words that we usually mean when we talk about an average or a central tendency, generally mean is the one that you think about when you think about average. The math term for average is mean. When you're looking for the mean of a data set, what that really means is that you are adding all of the numbers up in the data set to find the sum of the data set, and then you're dividing by the total number of data sets, the number of numbers, so to speak. So how many numbers did we have? So if our data set has 100 numbers in it, we add up all 100 of those numbers and then we divide by 100. So that is the average. So how many numbers are in the data set is what you're going to divide by, and then you add it up. And that's the average that most people think of on a common basis. Another measure of central tendency is the median. And when we talk about a median, we're literally talking about the middle number in the set. And so that does mean one thing is to find the median, you actually have to put your data set in order. You can't just have like this random set of data and it's all jumbled up. You have to put the data set in order. And so you would put it in order from least to greatest. And then for the median, you're actually literally looking for what is the number that is smack dab in the middle. Sometimes if you have an even number of terms in your data set, so let's say we had a data set of 100 again, the problem is that there's not a middle number when it's an even number. You know, I've got half of it's 50 and half of it's 50. So when you're looking for a median and you have an even number of data terms, what you have to do is you have to take those two middle numbers and then average them. So you still have a median, you just average the two middle numbers. But if it's an odd number, like 99, then there's going to be, 49 on one side, 49 on the other side, and there's going to be one number left in the middle. And so that would be the median. Mode is still kind of measuring what's going on in a data set. It's just we're not literally looking for the middle number or that average of all the numbers. The mode is just the number that happens the most often. So when you're looking at a data set, if there's one number that just keeps recurring, other people might have different things, but there's this one number that just keeps happening most frequently and over and over and over again. That would be the mode, the number that appears the most often, the most frequently. These are all measures of central tendency. What is the data set tending to act like? It's some way to describe a large data set of numbers. Range is not a measure of central tendency, but it does tell us, what ballpark we're in. When we're talking about numbers, numbers are infinite. They go on forever and ever and ever and ever. So if we have a data set, we can at least give the range of all the numbers in that data set, and it kind of tells us what ballpark are we dealing with. Where in the grand scheme of numbers in the universe, where are we actually looking at numbers? And so to find your range, you just take your highest number and you subtract your lowest number. And that kind of tells us how spread out are these numbers. Are these numbers clumped close together? Or are they really spread wide apart? If you have a range that's just 2, then all of your numbers are pretty darn close together. But if you have a range that's 3,000, then okay, we're spread out pretty far. So it's a little more talking about the spread. And a little later in the week, we'll talk about another way that we can talk about spread of data and how far apart data is. But mean, median, and mode are the measures of central tendency. So let's do a little practice here with how we actually do those computations for mean, median, and mode. So here I have some precipitation data measured in millimeters for a few years and a few months. And we're going to look at these. So in May, we can see over the course of about 4 or 5 years how much rain was falling in the month of May, or how much precipitation they got in the month of May. If we wanted to get like an average, again, you always hear the weather people talk about, this is above average, this is below average. We want to know, so in comparison, did we have a wet May or did we have a fairly dry May? What they do is they look at historical data and they have found some kind of average. So for mean, if I wanted to find the mean of May, I would have to take all of those May values and I would have to add them up. 69 plus 89 plus 38 plus 15 plus 124. Not 125, 124. So we would add all of those up. That would give us a sum. And then there's 1, 2, 3, 4, 5 pieces of data. So we would divide by 5. And so when we do that, we just take our calculator. You will find that a calculator is your best friend when you're doing this kind of statistical analysis. So when we pull up our calculator, all right, so we can add up all of those numbers. So we've got 69 plus 89 plus 38 plus 15 plus 124. Hit enter and divide by 5. We get that the mean was 67. And so what you can look at, again, this is a measure of the center. So in 89, they had way above average. That was a very wet May. But in 88, that's way below average. And so they were looking at a drought type situation in that May. It was way below the average. 85, they were pretty much right on the mark, right on the middle. Sometimes it's more, sometimes it's less, but this is what's an average. You take everything. Now, sometimes you have remarkably low numbers. For example, if you look at June's numbers, they had in 88, they had 5 millimeters. That's way below all of the other numbers. Far, far below. Looks like 60 below any of the other numbers. So it's not really clumped with the data. A lot of times we call that an outlier. And you will hear some more about that this week. We're going to talk a little bit more about outliers. And we're going to talk about the effect that those outliers have on a mean or a median or a mode. If we were looking for the median of this set of data, now remember the median is just the middle number. It's not an average, but it's the middle number. When we look at these numbers, the first thing to do when you're finding a median is you have to put the numbers in order. So the smallest number for May was 15, and then next was 38, and then next was 69, and then next was 89, and then the last one was 124. So to find the median, first you have to put them in order. And then when I'm looking for the middle number, an easy way is to start by, you get rid of 1 on each end. And then I get rid of 1 on each end. And then you keep doing that until when you finally get down to there's only 1 or 2 numbers left in the middle. So I got rid of 1 on each end, and that left me 3. I got rid of 1 on each end, and that left me 1 right here in the middle. So it looks like my middle number is my median, and in this case it's 69. So our mean and our median actually ended up pretty close together. They're both measuring the center of this group of data, so you would expect them to be somewhat close together. The last one we talked about was the mode. And the mode is a very interesting measure of central tendency. Depending on the type of data that you're looking at, mode can be very useful. When you're looking for attempts that people have done at something, and if you've got the most common, how many times does the average student take the SAT? How many attempts do they do? There's going to be a lot of different numbers there, but an average isn't necessarily what we're looking for, because it's going to say, 3.7 or 2.8. Well, I can't take the SAT 0.8 times. That doesn't really work. But if we look at it and we find out that the number of times that most of the students took it was 2, that would be the mode, and that would be another good way to show central tendency. When we look at this data set, though, we had 5 numbers in this data set, and none of them occurred more than once. This is a data set where mode is not actually terribly useful. Not every data set has a mode, and this is a case of a data set that has no mode. There's no number that occurred more than once. Sometimes you can have more than one mode. For example, if we had 2 numbers that occurred the exact same amount of times, and that was more than any other numbers in the group, you can have 2 modes, but you can never have more than 2 modes. So sometimes you don't have a mode at all. No number occurs more than the other ones. Sometimes you might have 2 because you had 2 numbers that occurred the same amount of times and they were more than any of the other ones. And sometimes you just have 1 number that occurs the most. Mean is the average, and we use that a lot, especially for data sets like this one, like rain. It works really, really great when you have no outliers, numbers that are really, really far off. Median works very, very good about getting into the middle of a set, and median kind of isn't affected as much by outliers. We use median a lot when we talk about like income for an area, the average income of people that live somewhere. Because if you have 1 millionaire in the neighborhood, that's really going to make your average offset when, the majority of the people in town actually probably make, $60,000 to $70,000 a year, but you have one guy that makes $1 billion. If you live in Bill Gates town, that's not really going to be, the average isn't going to work well there. But a median, it's talking more about, okay, here's this big group, what's in the middle? Then that billionaire just counts as one person. It doesn't really offset, that outlier doesn't affect it as much. And then mode, again, works really good when we're talking about things that we count or things that we do, but sometimes there's not always a mode, and so we can't always use the mode. But these are our 3 measures of central tendency. One other thing we did talk about was the range. So if we were looking for the range, it would also be important to have those numbers in order, because to find the range, we need the highest and the lowest. So for our range, we would do 124 minus 15. And that's going to be equal to 109. So we have a range of 109 millimeters for the month of May for its rainfall totals. So mean, median, mode, and range. One more example. Sometimes they give you a whole bunch of data in a table, but you don't necessarily need all of that data. For example, if I wanted to find the mean calories in a hamburger, what is the average of calories in a hamburger? I don't need all of these columns. I'm only interested in calories. So these are the numbers that I would want to focus in on. And again, mean, we're adding them up and then dividing by how many we have. So 250 plus 290 plus 230 plus 310 plus 470 plus 310 plus 140 plus 350 plus 310 plus 390. All right, that's all going to go on the top. We're adding them all up, and then we're going to divide by how many numbers are there. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 numbers. So let's do that. Let's add these up and find our mean. What is the average amount of calories in a fast food hamburger? So let's see, we've got 250 plus 290 plus 230 plus 310 plus 470 plus 310 plus 140 plus 350 plus 310 plus 390. There we go. So that's 3,050 divided by 10, because we said there were 10 numbers, so that means 305 calories. The average amount of calories in a fast food hamburger turns out to be 305 calories. Now, if we were going to do the median, we would actually need to get these numbers in order. So for the median, let's look at the median calories. So it's the same list. But what's our smallest number? It looks like 140 was our smallest number. And then we have 230 I believe, is the next smallest. And there's no real way to get around this, folks. You just have to look at the numbers. Now notice when I use a number, I cross it out. This means that I don't accidentally use a number twice or try to get things out of order. It really keeps me straight. After 230, it looks like the next one is 250. And then after 250, it looks like 290. All right, so now we're up to the 300s, and it actually looks like I've got 310, but I've got 310 more than once. So I'm going to be careful and make sure that each time I use one, I cross one out so I don't accidentally end up with too many of them. And then after 310 is 350. And then we've got 390. And then we've got this Carl's Jr. burger. I believe that is 470. Goodness gracious. All right, so another quick way to count and make sure you didn't leave something out. Anytime you're having to copy data over, it's really easy to miss a number. So I'm going to count to make sure I still have 10 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good deal. I have all 10 of my numbers, so I didn't leave any of them out. Now we said for the median, we want the middle. So I need to start crossing out some numbers on the end to figure out where my middle is. So 1 from each end, and 1 from each end, and 1 from each end, and then 1 from each end. Now, this was an even number. There were 10 of them. So the middle number, there wasn't going to be one exact middle number. There are 2 numbers in the middle here. So we're going to have to find the average of those 2 middle numbers. Now, we got lucky. These 2 middle numbers happen to be the same number, so that's easy to average. 310 plus 310 divided by 2 is just going to be 310. 310 plus 310 divided by 2 is equal to 310. So don't forget, when you're doing the median, if there are 2 numbers left in the middle, you have to find the average of those 2 numbers. If there's just 1 number left in the middle, then that is your median. And that's not too far off from our average. So that tells us that the outliers weren't terribly bad in this data set. The median and the mean were very close to one another. Now, this set of data did actually end up having a mode. This is another thing. When you put your numbers in order, it makes the mode a lot easier to find as well. When we look at those numbers in order, 310 was on this list 3 times. No other number got used more than once. But 310 got used 3 times. So the mode for calories would be 310 as well. It was the most often, out of all the hamburgers, that was the one that happened the most often. So it would be the mode.